Hi class, so module 4, this is about torsion and thin-walled vessels. Let's talk about muna si torsion. And let's recall yung mga basic stresses natin. So first is normal or actual stress, shear stress, and then bearing stress. Na pag-usapan na natin itong tatlo, they are the simple stresses in the previous modules. So, napag-usapan na din natin si thermal stress. And then for number 4, si torsional stress. So, torsion is the twisting of a structural member caused by unapplied torque. So, applied torque ito, this causes torsion. So, what is torque? We designated by capital T is the twisting moment of a force. So, moment of a force din siya, pero twisting ang effect niya sa body. So, it is the tendency of a force to rotate an object around an axis or pivot. Instead of bending, the member rotates along its longitudinal axis. The circular cross-section is an efficient shape for resisting torsional loads. Circular shafts are commonly used to transmit power in rotating machineries. So, for example, tingnan nga natin dito, how do we get torque or paano na nangyayari in real life yung torque or yung torsion. So, this is the most common one. So, sa steering wheel natin, sa mga sasakyan, so, paano ba i-drive ng mga driver or how do they use this steering wheel? So, if you are going or you're going to turn right, so you steer yung wheel sa right. So, you do that by, syempre, hawak ng driver dito sa point na to and he pulls it backwards and then dito sa kabila, he pushes it onwards or upward. So, as you can see, this is yung napag-aralan natin sa statics. This is a couple force. So, couple, they are also a moment, di ba? So, paano kung nasabing couples ito? So, they are, it is a pair of forces na parallel sa isa't isa and then different ang direction or opposite direction sila. And another thing, meron silang distance between each other and equal yung magnitude nila. Kung 10 Newton to, 10 Newton din to. So, this is a couple. Ito yung ina-apply basically ng driver para ma-turn right yung steering wheel. So, this couple, they are moment nga. So, umiikot sila paganyan. So, this is the direction of our example couple. Clockwise siya. So, anong nangyayari kapag may moment dito sa steering wheel na to? So, yung moment na to, ipapasa ng steering wheel doon sa cylindrical parang pipe na to. So, this pipe will receive the moment na yung couple. So, ano ang effect ng moment na to dito sa pipe, cylindrical pipe na to? So, since clockwise, so, ganito yung ikot ng moment. So, ano yung effect niya dun sa body? It is twisting, di ba? Niro-rotate niya yung body natin along its length, longitudinal length. Ito. So, dito niya iniikot yung body natin. So, that's a twisting effect. Next, dito sa bolt naman, this is the tightening of the bolt. So, paano natin tinatighten yung bolt? Siyempre, meron tayong wrench dito. So, yung wrench, parang hawak niya yung bolt dito, hawak niya din dun sa kabila. So, itong wrench na to, it applies also couple. So, para ma-twist niya, ganyan, kunwari, counterclockwise, the wrench applies a couple force na ganyan. Okay? So, nagtitwist din yung itong bolt head, yung head na to. So, itong head na to ang nagre-receive nung couple or nung moment. And then, ano ang effect ng moment na to dito sa shank or body ng bolt? So, kapag na-reach na kasi ng bolt yung very tight na siya, So, parang hindi na niya kayang bumaon pa. So, matotorsion siya. Meron siyang twisting na mararanasan dito. So, natotorsion siya. Natitwist din siya. So, this type of moment, yung couple natin, ang effect niya dun sa shank ng bolt is twisting moment. So, natotorsional stress siya. So, the same dito naman sa doorknob. Para ma-open mo yung pintuan, you need to exert force dito. Ipupush mo siyang ganyan. So, paano nangyayari ang moment dito? Since nandito yung center ng doorknob, meron siyang distance D. So, meron kang force times D. Di ba moment, ang formula niya is force times D. So, this is a moment. So, this moment will be received by the body ng doorknob. This cylindrical part ulit. So, ano ang effect ng moment na to dun sa cylindrical part ng doorknob? Siyempre, twisting din siya. Tinitwist niya yung cylindrical body ng doorknob. So, natitwist itong ating doorknob doon. So, next, sa mga rotating machines, so, paano nangyayari si torsion? Ito yung mga gears nila. So, this part, mayroong force na nangyayari, na-apply dyan. And since ito yung center ng ating rotating body, so meron siyang distance and may force ka, this is also a moment force times D. And then, ano ang effect ng moment na to dito sa body ng ating element sa cylindrical part niya? Siyempre, natitwist niya to pag ganun. Natitwist niya yung buong body ng element ng machine na to. So, that twisting is what we call yung torsion nga. And torsion, this twisting of the structural member is caused by the moment, which is a twisting moment, and that's what we call torque. Okay? So how does torsion happen sa mga beams? So, eto si girder. So, may girder tayo dito. And then, si girder may kumabit sa kanyang isang maliit beam. And then, yung beam na yan, carry ng force dito sa end lang niya. So, since eto si girder, nandito pa lang yung load. So, may distance yan. So, this is also a moment na equal to force times distance. So, ano ang effect ng moment na to dito sa girder? Siyempre, it is twisting. So, natitwist yung girder natin along its length na to. Natitwist siya. So, kung i-imagine ninyo, ito yung nangyayari sa beam. It is twisting na ganyan. Okay, so that's how torsion, torsional stress, and torque happens. So, paano natin na-compute yung torsional stress sa mga torsional members? So, meron tayong tinatawag na idealization, structural idealization, para, kumbaga, ma-analyze natin mathematically yung mga situations natin. So, number 1, circular cross-sections remain plane and perpendicular to the axis of the shaft. So, if this is your shaft, ito yung axis niya, longitudinal axis. So, yung cross-section ng torsional element mo, yung cross-section niya is ito. And kung hatiin mo siya dito, ito yung cross-section niya. If hatiin mo siya dito, yan yung cross-section niya. So, these cross-sections daw, they remain plane. So, flat lang sila and they don't warp. Hindi siya nagbabayo-bayutot, nabibend. Or hindi siya di-distort. So, this plane nga, they remain flat and plane and are perpendicular to the longitudinal axis ng member natin. And then number 2, cross-sections do not deform. Ayun nga, they will not deform, they babalo-baluktot or magwa-warp. And then number 3, the distances between cross-sections do not change. So, ibig sabihin, if from point A to point B, L ang distance, kahit applyan mo yan ng load, it will remain na L yung distance nila. Kung ito, yung distance nito is X, kahit applyan mo ng load, X pa din yung distance between nila. So, kasi nga, we are assuming na cross-section remain plane or flat and stays perpendicular to the longitudinal axis of the member. So, that way, na-idealize natin yung situation and our engineers were able to compute mathematically yung torsional stress and yung corresponding deformation. So, di ba nga, partner ang stress and strain. So, kung may stress ka, meron kang deformation, may strain ka. So, for torsion, syempre may torsional stress tayo. And that torsional stress is also a type of shearing stress, shear stress, no? So, bakit siya shearing stress? Kasi itong torque natin or yung magiging internal load niyan, internal torque is parallel doon sa cross-section. Diba sabi natin sa shear stress, it is caused by force na parallel sa cross-section. So, for this torsional stress, the torque, hindi nga lang siya force, it is a moment. The torque or the twisting moment is parallel to the plane ng cross-section. So, it is also designated as tau kasi shearing siya. And then for the strain, how does strain happens? So, or yung deformation niya. Since this is a type of shearing stress, ang deformation ng shear stress is, rotation, di ba? Si gamma, yung sa last lesson natin. So, twisting ito. So, angle din yung deformation niya. So, that's what we call si theta. We designate it as theta and we call it angle of twist or angle of rotation. So, saan siya nangyayari dito? Nandito si angle of twist. So, kino-compute din natin yan. So, how does it happen? Kung initially, nung wala pang torque, ang torsional member natin is ganyan lang, flat. So, meron siyang line na ito, from point A to point D, flat lang siyang ganyan. Initially, wala pang load. Pero nung in-applyan mo siya ng twisting moment, ito, syempre you expect the body to rotate to the direction of the moment, which is for this one, it is clockwise. So, mag-iikot yung body natin ng clockwise. Kaya from point B, pupunta na yung line natin dito sa B prime. Ito na yung new position niya. So, that is deformation, no? So, it is yung angle na theta. This is the angle of twist. And then, since point A, sa point A may support ka, so, since may support dyan, meron yung reaction. So, ang reaction niya, since ang load mo is a torque, so may reaction si point A, which is also a torque niyan. And that opposes yung direction and magnitude ng applied torque mo. So, if your applied torque is clockwise, edi counterclockwise ang reaction mo sa C. And then, syempre, to counteract, same magnitude yan. So, point A stays dun sa point niya. Dito lang si point A. And then, kapag nag-apply ng torque, etong point B ang mag-move, no? And then, point A stays dun. Kaya, angular yung kanyang twisting. May displacement dito sa point B, sa point A wala. Dahil fixed siya. May support siya doon. So, this causes, syempre, si stress natin, torsional stress. And then, meron tayong angle of rotation, theta, dito. So, that's the torsional stress and torsional deformation, which is si theta, angle of twist. So, we have the formula para ma-compute itong torsional stress and si angle of twist. Itong dalawa, no? So, what is tau max? So, tau max is the maximum torsional stress na ma-experience ng ating torsional member. So, if this is our cross-section, so nagkaroon siya ng torsion, meron tayong torsional stress dito sa point na to, sa point na to, sa point na to, hanggang dun sa surface ng cross-section ng member natin. So, if you want to get yung stress sa point na to, you use yung distance from the center up to this point. That's what we call zero. And then, if you want to get yung stress, dito naman sa second point na to, ayan na ba yun? Ito naman, so you need to get yung distance from the center up to this point kung saan mo gustong i-evaluate. This is now your raw na gagamitin. If ito naman yung gusto mong kunan ng stress, edi from the center to that point, that will be your raw. Pero if gusto mong makuha yung mismong torsional stress dun sa surface ng cross-section, edi ang raw mo now is equal to the radius mismo ng cross-section. Okay? And kapag kinuha mo ang stress dun sa surface, where rho is equal to radius, that is actually the tau max, maximum. So sabi, per theory, ang maximum torsional stress happens or it occurs dun sa surface ng cross-section natin. So, ibig sabihin, this is tau max. Yung mga tau or mga torsional stress na makukuha mo sa point na to, sa point na to, are less than the tau max. Mas less sila, no? Ito yung formula natin to get that torsional stress. So, ito yung general formula to get torsional stress at any point within the cross-section ng torsional member mo. So, tau is this is torsional stress. And then, this is T, your torque dun sa segment mo. That's the torque or the twisting moment. Force times distance. And then, yung rho, as we've discussed, ito yung parang radius or distance nung point kung na ina-evaluate mo to the center ng cross-section. And then J is the polar moment of inertia. That is a property ng cross-section mo. So, this is yung mga different formula for the polar moment of inertia for different cross-sections. So, sabi nga natin for torsional members, we usually use yung circular na cross-section. Pwedeng solid, ibig sabihin wala siyang butas, or pwedeng yung tube section, or may hollow, may butas siya sa gitna, hollow cross-section. So, itong dalawa ang usually ginagamit na polar moment of inertia. Pero kung ang section mo is a square or rectangle, kunwari beam, na rectangular beam ang gamit mo, so, ito yung J na gagamitin natin. So, sabi nga natin, if kinukuha mo is yung tau max, yung maximum that occurs to the outermost surface ng cross-section, R or the mismong radius ang gagamitin mo in place of rho. So, if you're getting tau max, again, R yung gagamitin nyo or the radius of the cross-section. And then, since ang mga shafts circular, ang mga torsional members natin are usually circular kasi nga circle is the best to absorb or carry torsional torque, torsional loads. Kaya merong derivation ng formula for tau max kapag solid circular shaft ka, ito ang gagamitin mo. Or kung hollow circular shaft ka, ibig sabihin yung may butas, yung mga may tube, ito ang gagamitin mo. So, basically, itong dalawang formula na to are just the same dito kay ito. Sinubstitute lang yung formula ng J for solid shaft and J for hollow shaft. Kaya na-derive tong mga to. So, any of them you can use for tau max or the maximum torsional stress. So, that's how we get torsional stress, no? So, next na kinukuha sa mga torsional problems ay si theta or si angle of twist. So, may dalawa tayong formula kasi yung isa, ginagamit kapag varying yung problem mo. Varying yung load, varying na cross-section. Ibig sabihin, from point A, 2-inch diameter, bigla sa next point niya, sa point B, 3/4 inch na lang. So, varying siya. So, pag varying ang case, so nag-i-integrate tayo. But if your load is hindi varying, your cross-section is not varying, you can use itong formula na to. So, T again is your applied torque. I mean, T is your internal torque. No, internal tong mga to. Internal torque, not the applied torque. So, these are the internal torque. And then, L is the length ng shaft mo kung saan naka-apply yung internal torque. And then, G is, you know this already, modulus of rigidity. Rigidity kasi nga, torsional stress is the same or parang si shearing stress din. Pag kay shear stress, di ba, G ang ginagamit. And then, J is your polar moment of inertia. Okay, that's for angle of twist. And then, next is power transmission. Sabi nga natin, torsional members are usually sa mga machines, rotating machines, they transmit power. So, kung ang problem nyo is about power transmission, we have this formula to get yung power transmitted ng torsional moment natin. So, T is your internal torque, and then P is yung power, and then 2 pi F, it's 2 pi, and then F is your frequency. That is yung mga variable or yung mga naka-hertz or RPM, revolution per minute. So, that's F, frequency. So, now let's try solving mga problems. And before that, sign convention pala. So, kapag nagdo-drawing tayo ng free body diagram for torsional problems, so, meron tayong ginagamit na sign convention and symbol. Kunwari, ito yung torsional member mo, it's a bar, tapos may torsion ka dito, may torsion ka doon. So, counterclockwise to, clockwise to, this is clockwise din to. So, nakakalito kung ganyan yung symbolism, no? So, kapag nag-free body diagram tayo, we use a double-headed arrow. So, kapag counterclockwise rotation, this is positive and going to the right, no? Counterclockwise, positive pa din tayo. So, ang double-headed arrow mo nun is to the right. Kunwari, ito, this is clockwise. So, for clockwise rotation, going to the left, and it is negative. So, at this point, may clockwise tayo. So, ang double-headed arrow ko is going to the left, and this will be negative. Kapag sa equations, negative ang sign niya. So, kunwari dito sa point na una, say this is, kunwari, counterclockwise natin siya. Counterclockwise. So, for counterclockwise, going to the right ang double-headed arrow. And sa equations, positive siya. So, ganun na TA and TB. So, ganun gawin ang free body diagram kapag we use double-headed arrow and then counterclockwise is going to the right. Kapag clockwise, going to the left. Okay. So, now let's answer na mga problems. So, let's answer problems. We have the, dito, mga formulas dito for the shearing stress, for angle of twist and power. And then we also have the formula for polar moment of inertia. So, let's answer number 1. So number 1, So, number 1, 2 inches ang diameter ng ating shaft. it is a solid steel. So, solid siya. So, solid, hindi hollow, sabi nga. And then, at point C, it is fixed. So, may support siya dito. So, may reaction yung point C niyan natin. And then, sa point B and point A, may mga applied na torque. So, number 1, determine the maximum shear stresses in segment AB and segment BC. Then, number 2, compute the angle of rotation of end A. So, co-compute yung angle of rotation dito sa end, sa point A. So, for shear stress, maximum shear stress, paano natin kinukuha? So, the same lang to dun sa normal or actual stress kung paano natin sila kunin kapag bar yung situation. Let's recall nga, paano ba natin kunin ang shear stress kapag sa mga actually loaded bars. So, kunwari meron tayong segment na ganyan. So, actually loaded at this point, meron siyang 5 Newton. At this point, meron siyang 1 Newton. So, and then, fixed siya, kunwari dito, may support siya doon. So, ay, saan ba yung point ko dyan? Ito pala. That's the point. So, paano natin kinukuha yung, actual stress dito? So, hindi natin ginagamit yung mga applied load, di ba? Hindi natin yan gagamitin. First, we need to get yung internal actual load na nandito sa segment na to. And then, may internal actual load din dito. So, first step, internal load. So, kukunin mo yung internal load. Next, kapag may internal load ka na, makukuha mo na si stress using the internal load. Since nakuha mo na si stress, next mo kukunin is yung deformation na. So, for torsional stress, paano natin kukunin si internal load? Nagsa-sections din tayo kagaya kay actual load. So, kung kukunin natin yung stress sa AB and BC, kailangan nating i-cut yung yung material dito and dito. So, pwede mong pipili ka, di ba, kung ano ang side ang gagamitin mo, if the right side or the left side. So, I prefer piliin nyo yung side kung saan may given, walang variable, or yung side na wala kang unknown. Eh, di ba, si point C is a support, so meron yung unknown variable, which is yung reaction sa point C. So, I would choose itong right side ang gagamitin kong for analysis kasi puro given lang yun nandito, walang unknowns. So, paano natin siya kinakat? Ika-cut natin siya from point A hanggang sa point right before B. And we will use the right side. So, kung ito drawing natin siya, ito yung bar. This is my point A. And then this is the point right before point B. So, that is right before point B. Ibig sabihin, hindi mo dapat isama yung applied load dun sa point B. So, now, sa point A, ano yung applied load natin? Let's draw na the applied load. It is a torque, which is counterclockwise ang direction. So, counterclockwise, that means a double-headed arrow going to the right. And TA is 900 pounds. Feet. So, meron pa bang applied load sa segment na to? So, wala na, no? So, now we can use equilibrium equations to get ano ang internal reaction or internal load dito sa section na to, dito sa point na to. Ito yung section. So, ito yung internal load niyan. So, by equilibrium equation, so equal to 0 ang mga torque. So, applied load is TA going to the right. So, that is positive 900 pounds-feet. And then, ano ang magiging direction nito? Say, kunwari, ginawa natin going to the right, si T, AB. So, this is the internal load ni segment AB. So, going to the right, so TAB. So, to isolate, kailangan natin si TAB, isolate mo siya. So, ita-transpose mo to. So, magiging siyang na negative 900 pounds-feet. So, naka-negative siya kasi it means mali yung assumption ng direction natin for TAB. So, imbes na going to the right pala si TAB, it is 900 pounds-feet going to the left. And that means a clockwise rotation. So, ito yung TAB natin. Next, let's get yung internal load sa segment BC naman. So, to do that, saan tayo magsa-segment? From point A, kunin mo yung right side ng material kasi mga given lang ang meron doon, wala tayong unknown. So, from point A up to a point right before point C ang ating free body diagram. So, this is point A. And then, ito yung point right before point C. So, at this point, kasama na si point B. Ito si point B. So, sa point A, meron tayong counterclockwise. So, that's going to the right na double-headed arrow na 900 pounds applied torque. And then, sa point B, it is a clockwise. So, that is a double-headed arrow na going to the left with a magnitude na 400 pounds-feet. So, eto na, wala nang ibang applied load. So, now we can get yung internal reaction doon sa segment BC. So, this will be TBC. So, hindi natin alam ang direction ni TBC. So, let's assume going to the right ulit. So, by equilibrium, so, everything is zero kapag in-equate mo lahat ng mga loads. So, first is yung 900 pounds-foot. So, that is positive 900. And then, sa point B, si 400 is going to the left. So, negative 400 siya, pounds-feet. And then, next is our internal load, TBC. It's going to the right, so positive TBC. So, wala nang ibang loads. So, let's isolate TBC para makuha natin magnitude niya. So, transpose yung dalawa. Magiging negative 900, magiging positive 400. So, how much is this? This is negative 500 pounds-feet. So, nag-negative ulit, meaning mali yung assumption ng direction natin for TBC. So, TBC pala should be, imbes na counterclockwise, it is clockwise. So, clockwise rotation din pala siya. Okay? Teka, may na-left out ako. So, nakuha na natin yung mga internal loads. So, check na to. So, next is, let's get the stress using yung formula for stresses. Ito yan yung mga T or mga torque na gagamitin natin. Ito na yung mga internal torque natin. So, what's the formula to get tau max? Tau max is equal to the torque times radius over J. Wait lang. Kailangan natin ang J. So, this is the J for a circular cross-section na solid. Ito ang gagamitin natin. You can use either ito or ito. So, let's get nga yung J ng circular shaft natin. So, ang diameter natin is 2 inches, no? So, let's use ito. Pi, diameter na 2 raised to 4 over 32. Let's compare nga. What if we use si J na equal to 0.098 2 raised to 4. So, pi times 2 raised to 4 over 32. Yun na yan. So, for this one, ang J natin is 1.571. So, kapag yung isang ginamit, 0.098 times 2 raised to 4, this is equal to 1.568. So, inch raised to 4 ang unit. So, may discrepancy kapag kapag iba yung J na ginamit. So, for this one, let's use na ito. So, kapag mag-use naman kayo, okay lang kahit ang gamitin nyo dyan. So, let's use that one. So, what's the formula for Tmax? It is equal to the torque, internal torque, times radius over J. So, let's get the stress muna for AB. So, maximum torsional stress for AB is equal to the torque. Write mo na yung formula, RJ. So, our torque for this one is 900 pounds-feet times R natin is 1 inch kasi 2 inches ang diameter. That's an R. And then J, what's our J? 1571. So, let's check the units. So, in inches to. Pero ito naka-feet. So, we need to convert this into inches. Itong feet na to. So, multiply natin siya sa 12 inch over 1 foot. So, ito na si yung foot is makakancel na. So, matitira na lang is magka-cancel to kasi may inch raised to 4 tayo doon. So, magiging 2 na lang to. So, what will be our final answer? So, 900 times 1 times 12 all over, all over 1.571. So, our torsional stress is 6,875 PSI or pounds inch squared. Okay? So, next, let's get tau max for BC. TRJ. So, what's the internal torque sa segment BC? It's 500 pounds-feet times R is 1 inch ulit dahil 2 inches ang diameter. So, we need to convert yung feet into inches. And then, all over. Same lang naman ang uniform ang ating cross-section. So, same lang ang J niya. Yan. Now, let's evaluate. Cancel na to. Cancel ito kasi may inch 4 doon. So, 2 na lang to. So, ang naiiwan na unit is pounds and inch squared. So, that's PSI. So, this is equal to 500 times 12 divided by 1.571. So, this is 3819 PSI. So, that is also, PSI is also pounds inch squared, no? So, this is our stresses. So, nakuha natin si number 1. Number 2 naman, it asks for the angle of twist. So, ang G natin is 12 times 10 raised to 6 PSI for steel. So, angle of rotation up to the end, no? Sa point A. Point A. So, yung total angle of rotation. So, remember, may nagsisegment din dito, di ba? Noong sa actual stresses and strain, by segment din tayong kumuha ng deformation, di ba? So, the same dito sa torsional stress, torsional deformation, by segment din ang pagkuha. So, meron kang angle of twist. Kasi tingnan mo, dito sa point B, counterclockwise. Hindi, clockwise ang rotation. So, ang angle of twist niyan is paganyan. Going clockwise din. Pero kapag titingnan mo sa point A, ang angle of twist niyan, mag-uumpisa dito. And then, angle of twist niyan is counterclockwise. So, babalik siyang pag ganun. So, expect na parang magma-minus sila, no? So, kapag different yung direction ng loads mo, nagma-minus yung strain or deformation. Parang dun sa axial, may segment kang nag-contract, may segment kang nag-elongate. So, nagma-minus silang dalawa. Dito, nagma-matter yung sign convention natin. Na kapag clockwise, negative. Kapag counterclockwise, positive. So, be careful dun sa sign nyo kapag nagkukuha kayo ng, ng angle of twist. So, since ang pinapakuhang angle of twist ng problem is hanggang point A, ibig sabihin, kukunin mo yung angle of twist sa segment na to, kukunin mo yung angle of twist dito. And then, nakadepende sa sign convention kung mag-a-add sila or magma-minus. So, let's get na yung total angle of twist. So, ang angle of twist natin, it is from point C up to point A. So, ano ang angle of twist natin sa segment BC? And ano ang formula natin for angle of twist? Since hindi naman varying yung load natin, ibig sabihin, ito ang gagamitin natin. Hindi rin varying yung cross-section. TL over GJ. So, let me just write dito. TL over GJ. So, angle of twist for segment BC muna. That is T angle for BC. Length ng BC over G. Since BC is still and AB is also still, isang G lang sila. And then, since BC is 2-inch diameter and AB is also 2-inch diameter, isa lang yung G nila. So, yan. So, that's the angle of twist for segment BC. Ano ang angle of twist for AB? So, ilagay mo yung T, torque sa AB, length ng AB, and then GJ. So, same lang sila ng GJ na. So, kung gusto mong i-simplify, magiging ganyan sila. Since isa lang kasi yung GJ nila, na? Same denominator. So, algebra natin yan. So, let's substitute now yung mga value ng variables. So, what is our torque sa section BC? This one, si 500. So, again, be careful of the sign. Importante yung sign convention. Since clockwise siya, so this is negative. Negative 500 pounds-feet times length ng BC. What is the length of BC? It's 3 feet. And then 5 feet si AB. So, 3 feet, no? 3 feet. So, that's the length. And then, kay TAB naman, what's TAB? It is negative na 900. Negative 900 pounds-feet. And then, ano yung length niya? It's 5 feet. All over G. What is our given G? It is 12 raised to 6 PSI times what is our J 1.1571 inch raised to 4. So let's check the units. Meron tayong inch, may naka-feet. Ito, naka-feet, 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 feet. So, mas mahirap mas mahirap i-convert ang mga inch raised to 4 and inch squared. So, yung walang exponent ang i-convert natin into inches. So, those are, ito, convert natin atong apat na to. So, equation will be times 12 inch over 1 foot times 3 feet. Kasi 3 feet din kailangan inches. Plus negative 900 pounds feet. Convert 12 inches, 1 feet, 1 foot. Times 5 feet. So, convert 12 inch, 1 foot. So, that's for the numerator. Si denominator, as is lang siya. PSI, papakita ko yun lang yung PSI. PSI is also pounds inch squared. 1.571 inch raised to 4. So, let's do the operation. How much na ito niyan? So, it's negative 500 times 12. Nasaan ako? Times 3 feet times 12 minus 900 times 12 times 5 times 12 all over, that's this, 12 times 10 raised to how much? 6 ay naka times 1.5 ay mali 571 raised to 4 inch raised to 4 pala. So our answer is 0.046. So ito yung nakuha nating theta from point C hanggang point A. So kapag ginamit nyo itong formula na to, ang unit na result nito is radian, no? Pag ginamit mo yung formula na to, always ang theta is in terms of radian. So kailangan natin i-convert ang radian into degrees. So paano natin i-convert? Anong conversion? Ano to? Degree, no? 180 degree is equal to 1 pi. So this will be equal to, our answer is 2.636 degrees. So ito yung answer natin. So kapag nagko-compute tayo ng angle of twist, ang unit natin should be, ang ending unit should be in degrees. So makukuha natin radian, you need to still convert it into degrees.